So I'm going to rewrite this as log base 10 of 25x squared. Why base 10? Well, base 10 is what you consider a common log. So when there is no base written, it's automatically a 10 every single time. You don't even have to question it. It just is a 10. And now we can... Okay, so now that I've combined the logs, you have log base 10, 25x squared equals 2. You've got to get rid of the log base 10. So the inverse of a log is exponential, and that's what your teacher's trying to get you to do here, is rewrite this in exponential form. So we like to use an acronym called BOB. BOB stands for base, opposite, and back. It's just a short acronym to help you remember the order in which to rewrite something from logarithmic form to exponential form. So starting with, I'm going to use a different color here, the base of your log, so starting with the base, and then you go to the opposite side. So base opposite, so 10 to 2, so it's going to be 10 to the second power, and then you go back. And all of that is going to be equal to 25x squared. So now you can solve this like a normal equation. 10 squared gives me 100. So I have 100 equals 25x squared. And now I can divide both sides by 25. 100 divided by 25 gives me 4. And 4 is equal to x squared. And now we can take the square root to solve. So the square root of 4, we get x equals technically plus or minus 2. So you really have two answers. But if we go back up here, your arguments have restrictions. So your arguments are the x squared and the 25. Your argument can never be negative. So negative 2 is an extraneous solution. So your only solution is x equals 2. Hope that helped. If anyone has any more questions, feel free to ask. You know what? I got to backtrack here a little bit. Because x is being squared, I forgot the square was there. Because x was being squared, negative 2 would also work. So we actually have two answers. Sorry, going live, I guess you're bound to make a few mistakes here and there. Hopefully this helps. And you're checking, do they have the same base? Which they do. And now we can see that they're being added. So when two logs are being added, we are actually going to multiply the arguments. So let's rewrite this. We're going to have log base 2. And we're going to rewrite this as a single logarithm. We're going to have 4 times x minus 9. And then all of that is going to be equal to 5. All right, so now I'm going to simplify inside my argument and distribute that 4. So I'm going to have log base 2, let's see, log base 2 of 4x minus 36. And all of that is going to be equal to 5. So in the last example I was talking about, I mentioned BOB, B-O-B. Now, BOB is an acronym that I use in my classroom that stands for base, opposite, back. And BOB is just to help us remember the order in which to rewrite a log function as an exponential. So starting with the base, which is 2, raising it to the opposite side. So base, and then I go to the opposite side. So 2 to the 5th power. And then we go back. base opposite back. So 2 to the 5th has to be equal to 4x minus 36. Now we can really treat this like any other equation. So I'm kind of running out of room, so I'm going to zoom in here a little. Actually, I'll stay zoomed out. 2 to the 5th is going to give me 32. And then I have 4x minus 36. I'm going to add 36 on both sides of the equation. So let's see what that's going to give me. Just a little bit of mental math there. I'm going to come over here now. 32 plus 36 is going to give me 68. All right, so 68 is equal to 4x. And now we can divide both sides by 4. Let's see, 4 goes into 6 evenly once with a 2 left over. So that is going to give me 17. So x is equal to 17. And personally, I like to highlight things. So I would probably highlight that. X is equal to 17. Now, like I said in the last problem, you do want to make sure that your argument, like when I get x equals 17, if I plug it back in for x up here, you're making sure that your argument doesn't become negative. So for instance, if I had 17 minus 9, I'm just double checking that that isn't a negative number, which it isn't. So that works out perfectly. And this is our final answer, x equals 17. I can rewrite this as log base 3 of x times x plus 6. And all of that is equal to 16. Oh, this is a good question. This is actually a really good question. Okay, so here, go ahead and distribute your x to the x plus 6. So really just cleaning that up a little bit, just making it a little neater. So I am going to have log base 3 of x squared plus 6x, and all of that is equal to 16. Y16 plus 6x, and all of that is equal to 16. Y16 plus 6x, and all of that is equal to 16. Y16 plus 6x, and all of that is equal to 16. Y16, was that? I'm so sorry. There we go. Okay, thank you. Sorry about that. Like I said, this is what happens when you go live. I'm bound to make a few mistakes here. Okay, all right, so, okay, perfect. Here, we're still good. I would not have changed anything I've done so far. I would have continued to add these logs by multiplying the arguments, which is what we get right here. Now, you have exactly one log on each side of the equation. So if we think about this, if I said 2 equals 2, that's a true statement. 2 does equal 2. I think we can all agree on that. What they're saying in this problem is log base 3 of this argument has to equal log base 3 of that argument. Well, if both sides of the equation are equal and they're both log base 3, then what I can do is drop the log base 3's and get them out of the way. We already know log base 3 is equal to log base 3. Now we can say, okay, x squared plus 6x has to be equal to 16. And that's, again, because I had exactly one log on both sides of the equation. So now I'm left with x squared plus 6x equals 16. And while I like this problem, oftentimes a lot of my students don't really like this problem, because what do you notice? You have x squared, 6x, and a constant. That almost looks like a quadratic expression. So we are going to move that 16 by subtracting it to the other side of the equation. Now you have a quadratic. Now you have to factor. And I know we don't really like factoring, but it's really not too bad. Okay, so let's tackle this. All right, let's draw our parentheses. Okay, now ask yourself, how does x squared split up evenly? It splits up x times x. The x method. Do you mean this? Where I think it's, what is it, 6? Is it 6 at the top and 16 at the bottom? Is that what you're thinking of? Okay. So, but you're exactly right. I think at one school I taught at, we called that the diamond method because it kind of looked like a diamond. Oh, 16 at the top. Okay. Not a problem. I can scribble that out. Scribble, scribble. Change that to a 6 and that a 16. Okay. So basically, you're looking for negative 16. I swear, where would I be without you right now? Okay, so negative 16 at the top, 6 at the bottom. We're looking for two numbers that multiply to give me negative 16 and add to give me positive 6. Okay, so we need two numbers that multiply to give me a negative and add to give me a positive. Well, if they multiply to give you a negative, you know one of these numbers has to be a negative and the other one has to be a positive. And if I add them, the larger number needs to be positive because when we add them, we have a positive number. So what numbers multiply to give me 16? Well, 1 and 16, 2 and 8, and 4 and 4. So that's really only the options we have. And if we had negative 2 and positive 8, they add to give me positive 6, and they multiply to give me negative 16. So now we could rewrite this as x minus 2 and x plus 8. Awesome. And now we can solve. All right, so setting both of these factors equal to 0, I have x minus 2 equals 0. So I get x equals 2. And then I have x plus 6. Oh, excuse me, not 6, 8. Get out of here. There we go. X plus 8 is equal to 0. And then if you subtract 8 on both sides, you get x equals negative 8. Okay, so like I said, I'm going to highlight. Pick my bigger highlight. You have two answers here. X equals 2 and x equals negative 8. But you have to check your arguments. If you take one of these numbers and put it into the argument, does your argument become negative? If your argument becomes negative, then that answer is really not a solution. So you found an answer, but not a solution. So if I plug in 2, that's no problem. 2 plus 6 gives me 8. So 2 is definitely an answer. And if I plug in negative 8, that argument is going to become negative, and that argument would become negative. So 8 is not an actual solution. It was an answer, but not a solution. So your only solution here is 2. X equals 2. So hopefully that helped. But these are really common problems where you're going to have to factor, and you've just got to be on the lookout for, okay, I have a squared term, an x term, and then a constant. Get everything to one side of the equation, set those factors equal to 0, and then you have to check. If you're going to have an answer that's not actually a solution like we did here, it's going to happen on a question like this.